All right. Hi, everyone. So as you all know, this meeting is recorded and will be uploaded to YouTube. So June 4th. Okay, let's start with the component config to beta. Aldo. Aldo, you're muted.
Sorry. Yes, we did the upgrade of V1 Alpha 2 to V1 Beta 1. And we have the bin timeout changes for, is it for review actually? Let me check. It's already merged, yes. So, no, not this one, sorry. Yeah, so we're still pending the bin timeout changes for the volume binding plugin. And then the merging reserve and unreserved plugins into one. But whoever is needing to do work in V1 Beta 1, now they can work on it. Also, I discovered that we had some extenders dependency that had some API violations. Basically, we didn't have strict decoding, and there was a type which was a duration type, which was a number. So it's the time to fix it now. So we shouldn't bring this to beta. And that's it.
So when we graduate this to GA, how would that coexist with the older?
Right. So when that happens, the thing is that this extender type is shared with the policy API.
Okay.
So we have to, while we still have the policy API, we have to basically rename the existing type so that we can have both coexisting.
Okay, and we keep supporting it through the policy, which could be passed through the flag, through a flag.
Yes. So I would say once we GA the scheduler configuration, we can finally remove the flag in 2 more releases.
I thought it has to be 1 year because policy is GA.
Since 1 year since when?
I think since we have like a GA alternative.
A GA alternative?
Yeah, so basically once component config itself is GA, then I think like, yeah, it needs at least a year to deprecate the older GA alternative.
Okay, makes sense. Then we will stick with this for a while.
Yeah.
But yep, that's the plan.
Sounds good. You got multiple issues related to performance improvements.
Yeah, I can. Yeah, this is just a summary on recent performance improvements we did. Not all the performance improvement we did, just some of them I think we need to highlight them. So it can both improve the scheduling throughput as well as avoid some tricky flaky in your environment. The first one is given by Abdullah, which is to sort of when you do preemption. So the old logic is there will be 2 API calls. The first one API call is to update the preemptor path nominating node name to the node we preempted some paths to make room for the preempted path. So this is the first API call. The second API call is as usual, because the preemption only happens when filter all fail. So we are going to update the path status to unschedulable to the path spec not pod status updated condition. So there are two API calls, but it's not necessary to have two calls. We can merge them into one. This is not only related with reducing the API cost number, but also I think reducing some chances to having some cache and inconsistency, as well as some other unexpected bugs. This is the first one. Second one is to so during we update the pod status to API server, saying that the pod gets unschedulable. Inside that function, we call it make error function. Inside that function, the old logic is spinning up a Go routine to try to fetch the live version of the pod and using some backoff logic there to update the pod status. But that's sort of unnecessary because you're spinning up a queue, so you generate some chances to have racing with some other either main scheduling Go routine as well as some other Go routine happens on the same time. So the second PR is make that call synchronously. The second one. And third one is the category of optimization on our logic of deciding when to skip the pod update. So the skip pod update is necessary because usually when a scheduling cycle finishes, we do a step called optimistic concurrency, which is just we assume the pod has been specified with the spec host name, so that when the real pod update comes inside, we can skip that pod update because in our internal cache we have already has known that. But because some extra fields is handled in API side, so in the assume phase we cannot know all those fields has been updated. So we in the skip pod update we strike those kind of fields as best we can. But sometimes API server or some other API spec has updated, resulting the skip pod update is not up to date. For example, we have server-side apply, so that means there your spec manager fields will be updated by the API server. That is inconsistent with our internal assumed cache. So we need to strike all those fields as well. So these three PRs are handling this kind of events.
Sorry, when we the reason we're skipping a pod update, or like the side effect of that, is that we're not going to update it on the in the queue, right?
Yes.
And which means what? I'm just trying to follow the code. So if the update happens, what is the is that a performance penalty that we're gonna try the pod again?
Yes, exactly.
Unnecessarily.
Yes, correct.
Okay.
Yeah, so this is the sort of summary about our recent performance improvements. But of course, we have some other performance improvement like pod affinity, as I mentioned in last week's call. Yeah, this is not full list, but just some recent update. And
yeah, anyone have any questions on that? Comments? Okay, the next update is on the preemption refactoring that Way is leading, and the new post filter extension point that is basically being introduced as a result of trying to refactor preemption into a framework plugin.
Yeah. So basically, there are two things we should sort of discuss to agree on. The first one is that the real semantics of postal filter. So in the first version, I just thought of is the postal filter is a generic interface for preemption-like behavior. That means it should be only called after the filter phase failed. So it's a total replacement and extensive usage of preemption. And that is sort of agreed on, right, Abdullah? Because we don't want it to be called, no matter filter succeed or fail, right? We just want it to be called right after the failure of the filter. Right. This is the first point we want to agree on.
I agree with that. Initially, I thought we could have that extension point like called all the time, basically similar to what we had before removing it. But now that we have pre-score, it kind of like we have now two extension points being called basically at the same like close to each other, but one will be called only when the filtering phase actually identifies some feasible nodes, which is pre-score. And with post-filter, I mean, with the semantics of having it for changing the cluster state to potentially allow to schedule the pod in a future cycle. In this context, I agree that it should only be called on when the filtering phase fails to find at least one feasible node. And the other reason is because we want to stop fast. So if we were to make this completely generic, then we have to always execute all the plugins. Yeah. But if we wanted to execute only on failure, then that would allow us to exit early once one of the plugins says that, oh, I changed the cluster state and I believe that the pod is schedulable in the next scheduling cycle, so you don't need to keep executing other post-filter plugins. And so you can imagine, as we argued in the issue, you can have multiple preemption plugins that have various like levels of complexity, and you're trying them one by one. And so you should stop earlier if one of them succeeded. And the idea is that ideally you would have them ordered in term like in their complexity, how complex they are and how expensive they are. That doesn't prevent having like informational plugins, as Aldo mentioned also in the issue, where if you want, for example, to record some metrics there related to the fact that the pod was unschedulable, but cluster operators needs to be aware of how that those should be configured in the scheduler component config such that they are executed first, and they always return unschedulable, which makes sense. Like the plugin, the informational plugin, is not going to make the pod schedulable, so it should return unschedulable. Still, like maybe basically maintain the previous state, and that allows us to have reasonable, predictable, I guess, behavior of what to do with the various states that we expect from post filter. So we have 3 unschedulable, meaning that I'm going to continue executing the post filter plugins. The first plugin to return success, we're going to assume we're going to stop and say, okay, we're done. We're going to return. I'm just going to assume that that plugin found a solution or changed the cluster state to make the pod schedulable. And error is always error. All error should always be an internal error. Something wrong. The scheduler state itself is inconsistent or something wrong, unexpected, and we should break there. Like that's it. We should return. I don't know. We report an error, and that's and that's it. So yeah, exactly. So that's something we agree on.
Yeah. And the second thing is more very detailed design. Whether we should expose the preemption needed information as a parameter to the post-filter function, or we want to exposing it more to a higher level to a framework handle. So according to Abdullah's comments, that the parameters we define in each extension point function should be sort of transient and only associated with that particular scheduling cycle, like what we did, like cycle state, the path, as well as some snapshot was, it's sort of a transient state of that scheduling cycle. So based on that design rationale, I sort of agree that we should expose the preemption needed information to a more higher level to the framework handle, so that those kind of information, like nominated pod map, is a global state that change along the whole life of the scheduler. So based on that point, I sort of agree.
Yeah, I mean, the argument is also to simplify the function signature. I mean, again, since this is global state that is valid across scheduling cycles, might as well having it accessible directly through the framework handle. I mean, there's an argument by Alder saying we need to make things like, limit the scope or like separation of concerns. I agree with that. The problem is this increases the burden on our side of deciding what to expose where. And I don't think we can even enforce it, because anyone can take a pointer and store it in their like plugin state and have it accessible through the different extension point invocations. And so I would rather not like be opinionated in this for this. Like it's just like have the function signature as simple as possible. And yeah, that's I guess my point.
Right. So I guess we don't have any scenario of security.
No.
Because the binary is all trusted.
Exactly. Yeah. And it's yeah. Okay. Anyone have any questions on all these?
So what's the conclusion regarding where or not to break early?
Yeah, we had this discussion on the issue. We are going to, like in the post filter, you mean, right?
Yes.
So we will break early on success or error.
Okay.
So success means we change the cluster state successfully to make the pod schedulable, which basically is sort of consistent with this success semantics in other plugins, which may basically says that, which is synonym to schedulable.
Yeah.
Okay. Sounds good. Yeah, we should just document that properly in the API definition and in the documentation.
Sure. I will do that. Yeah, this is pretty much some pending discussion on the post filter. And other than that, I think we all agree on some other aspects as well as the implementation. So, but if you have any comments, just let me know.
So one last item I have, and then open the floor for any other discussions or questions not on the agenda. So I'm working on defining some benchmarks to better evaluate preemption and preemption path, basically, and any logic that gets executed when we fail to schedule a pod. So I already have one benchmark added. I'm working on a second one as well. So the first benchmark was trying to evaluate preemption itself. So it creates a bunch of low priority pods that gets scheduled. Once those pods are scheduled, we benchmark how fast it takes, how like the performance of the scheduler to schedule an equivalent number of pods in place of those init lower priority pods. So basically, for each pod for each pod that we're testing, it's going to evict a bunch of init pods, lower priority ones, and so forth. So that allows us to evaluate preemption plus like the whole preemption thing. So the second benchmark that I'm working on right now, it evaluates sort of like head of line blocking as well. So what the benchmark does is it creates a bunch of unschedulable init pods. Those stay in the system. And then the benchmark starts to create schedulable pods and sees how fast we can schedule those schedulable pods while we have, I don't know, 5,000 unschedulable pods in the queue. That keeps, coming back and clogging the queue. All the pods have the same priority. It's just that the unscheduled pods are going to consume some cycles and make the scheduled pods slower to schedule. So I want to evaluate that scenario as well. Have a benchmark there for it to stress like to evaluate some code paths that we have in the post, in the logic that comes after deciding that the pod is unschedulable. I don't think we had any benchmarks before to evaluate that, and so I'm trying to create a couple of canonical ones to use as a way to always evaluate to make sure anything we do there is we have some sort of like a reference point. What was the performance and how the new logic impacts things. So that's all I have. I do have an optimization, a funny one, which is basically we've faced before. Related to this, we have like a formatting line, like a log line that is at actually v3. It's not getting printed, it's just getting formatted, but it's in a very tight loop there. And it consumes like, I don't know, 30% of the execution time of my benchmark. And so we need to find a generic solution for these types of really annoying, like you look at the code, you wouldn't think that this is something should have any impact, but it does, because the formatting of the log message happens before evaluating the log level. And so yeah, it is what it is, I guess. Yeah, that's all I have. Any other questions, concerns, or comments?
Well, I asked you before if you run the benchmark for the fix that we already did, the merging of what update. Just out of curiosity.
I don't think it will impact too much in that benchmark, because we run everything locally and the API server is on the same, it's just a Go routine inside the same binary, right?
Yes, it still has to write to etcd, if I'm not mistaken.
Yeah, I'll do that. I'll check out an older version and the one before the optimization and report on the issue itself, on the PR. I mean, comment on the PR.
Yep, thanks.
Okay, thank you, everyone. Bye.
Thank you.
Thanks, bye.
Thanks, goodbye.